Hey there, Science 20. Well, we're going to talk about inertia and the laws of motion today. And this is going to wrap up our topic one. So that means we're going to have a quiz coming up pretty quick here. So I hope you guys are getting ready for it. Let me just move me out of there. That way we can see what's going on here. Okay, so we're going to start off talking about Newton's laws of motion. Now he's got three that we're going to talk about. Some are going to involve some calculations. So we'll just start with the first one. First one deals with a little something we like to call inertia, where we say that an object will undergo uniform motion unless acted upon by an unbalanced force. Now, some people kind of condense this or put it into simpler terms by saying an object in motion tends to stay at motion and an object at rest tends to stay at rest unless acted upon by a different force. So just remember that staying at rest, zero motion is still a form of uniform motion. But what this means is that we're going to need force to accelerate an object. And that's where his second law of motion comes in, where we would say that if an unbalanced force does act on an object, it will cause that object to accelerate. And we're going to start talking a little bit about the force of friction here as well. But anyways, let me just show you an example of this here. So here we have in our first problem, a net force of 10 newtons east is used to push a 15 kilogram object. What is the acceleration of the object? So we've got our variables here. Remembering that since east is in a positive direction, our force is going to have a positive direction. We then will use this formula here where the net force equals mass times acceleration. But we want to rearrange that formula so that we can isolate for the acceleration variable. So we divide both sides by the mass. 10 newtons divided by 15 kilograms is 0.6 repeating meters per second squared. So we're going to round that to 3 sig digs, 0.667 meters per second squared. Okay. So maybe take a moment, pause the video right here, go through those calculations yourself. Take your calculator and actually do the calculation yourself here. All right. We're going to up the difficulty just a little bit over here. So here we talk about a car with a mass of 1,000 kilograms accelerates uniformly from rest. So the initial velocity is going to be 0 meters per second to a velocity of 23.0 meters per second south. So final velocity is negative 23.0 meters per second. Remember, north is typically positive and south is negative. And this is going to be done in 10 seconds here. What is the net force acting on the car during this acceleration? So in this regard, the way that we would solve for this is we would take the mass times the acceleration, but I'm not giving you the acceleration. However, you can find acceleration by taking the final velocity, subtracting from it the initial velocity, and dividing it by the time, like we see here. And then we kind of substitute that in for A. So this is what it would look like. So we've got our mass, which is 1,000 kilograms. We're going to multiply that by our final velocity, which is negative 23.0 meters per second, minus the initial, which is 0 meters per second. And we're going to divide that by 10 seconds. Okay, so 1,000 kilograms is still going to be our mass. Our acceleration is negative 23 minus 0 is negative 23. Divided by 10 is negative 2.30 meters per second squared. And that's going to give us a net force of negative 2,300 newtons. Let's keep our sig digs. We need to have them at 3. So negative 2.3 times 10 to the 3 newtons. Okay. Now, if the force of friction is between the road and the tires of the car is 500 newtons north, how much force was actually being applied to the car in order to cause this acceleration. One thing we need to remember about the force of friction is it will always be in the in the opposite direction of whatever the velocity or force is of the object is. And so in this case, our total force is going to be the net force acting on the object. I need to put these are sorry, vector quantities divided by the force of friction, or plus the force of friction. So negative 2,300 newtons plus 500 newtons, and that's going to equal negative 1,800 newtons right there. Okay. All right. Now, third one, for every force, there's an equal and opposite reaction force, or for every action, there's an equal and opposite reaction. So for example, when you push against the wall pushes back on you just as hard, but in the opposite direction. If you somehow pushed with a force greater than the returning force of the wall, you'd push the wall over. But since you're not pushing the wall over, whatever force you're applying, the wall is pushing back to you. So in this picture here, we see the person is pushing against the wall with a force of 100 newtons. Since the wall is not moving, it's going to give you a 100 Newton push the other way. If you're sitting on a skateboard, when you push the wall, it will push you back and you will end up moving away from the wall. Okay. Now, applying force doesn't always work to move an object. This means we need to overcome the frictional force. So static friction must be overcome by the force that you apply. Otherwise, the box will not move. So anyways, that's all that I got for you guys today. Here's your homework to work on. And so if you got any questions, please let me know. And again, quiz is coming up. Be ready for it. If you have any questions, email me, ask me in class, and we'll see you in our next topic in the next video.